Welcome to the first video in the language technology unit. In this video, we are going to be talking about the two main types of language technology, how language technology is constructed, so what resources are needed, who generally makes these resources, who generally makes the language technology, and what role do we as community linguists and language technologists have in the creation of these resources. We're also going to be talking about the advantages and disadvantages of these two main types of language technology. So language technology can be divided into two basic types. There is the basic language technologies versus the intelligent language technologies. Basic language technologies do not require a language model. That is something that actually teaches the computer how to use or speak or write a language. Often, these technologies are essentially a word list correspondence. So, an online dictionary that can basically be a word in one language and a word or set of words in another language. These don't have a language model underneath them, but they do associate two words across languages. This can also include things like QR codes, which we'll talk about in a later video, but are essentially ways of linking to a website in real space. Basic online word lists and videos, basic language learning lessons that don't have sophisticated language models behind them, etc. So here we have a Blackfoot Dictionary. There's actually no banner, but there should be there. I don't know why it doesn't load, but here I'm searching for the word jump, and you can see it gives me two returns. It gives me the word jump in English and the word buffalo jump in English, and if I were to click on those, it would give me Blackfoot translations. However, if I wanted to look at the previous version or the past version of jump, so jumped, what we would find is that it's not giving us anything. It says jumped, not found. And that's because this Blackfoot Dictionary does have an entry for jump, but it doesn't recognize that jumped with ed is a past tense form. And so it ends up giving nothing in result. To create basic technologies, you need relatively basic resources. So things like a list of words, pictures, sound, and these can be put together relatively quickly. There's still, of course, the time that actually goes into eliciting all of these words and recording the speech, but once those are done, the actual technologies can be created simply and quickly. Even though most of us here are not programmers, the documentation that we create, that is, the descriptions of the languages we're working with, are used with less processing than in an intelligent system. And what that means is that there's a lot less learning going in to create a system. Instead, they're using our data as is. Our linguistic documentation is arguably the most time-consuming aspect of creating these basic technologies. Although web design, of course, takes time, and putting things online takes time, and organizing information is important and time-consuming, a lot of the time the hardest part is actually going out and getting those raw data to put online. Conversely, if we talk about intelligent technologies, we're talking about smarter technologies. These are technologies that use a language model. They have an understanding of a language. They can create a past tense form. They can create a plural form. They can create a question form, and so on. These are extremely versatile and user-friendly. They would allow me to, for example, in that last example, I could search jumped with ed at the end, and it would recognize, that's a past tense form of jump. I will give him jump and the relevant past tense form in the language. However, they are much more time-consuming to create and technologically demanding. Depending on how you create your technologies, which we'll talk about in a few seconds. These can require professional grade computer setups, software farms, server farms, etc. But let's talk about language models. So a language model is a system that contains the grammar and phonology of a language. It's ideally capable of creating any word or any sentence. So rather than giving it a list of words, because we're almost definitely not going to be able to give it a list of every word in the language or every sentence in the language, at least on the sentence level, that's theoretically infinite. What we do is we teach the computer, here's how you construct words, here's how you construct sentences. Doing this requires specific coding and programming knowledge. So either you need to know a programming language like Python or awk or C++ or C# or C even, or you need to understand how deep learning is done, and that is probably going to be making use of a programming language, so in the end, really, you're going to need that. There's two main ways to build a language model. So there is the rule-based model and the machine learning-based model. Rule-based models are built by hand. They usually require extensive linguistic documentation and are generally an older form. They have fallen a bit out of use in the last few years. They are still widely used, but they are not the up-and-coming technology that's fancy and trendy. And they can be time-consuming to create. So on the screen here, in the black boxes, we have an example from a real-life rule-based model. And basically what we're saying here is we are associating the tag plus 3PL, which means third person plural, with the form WAK, walk. So this would tell our system that any verb that is in the particular group that I pulled this from, if you want a third person plural form, the they do something form, just add walk to a stem. So if you have something like bimoteo, the stem is bimote. If you want to create third person plural to say they walk, you would say bimoteoak. Alternatively, below we have a phonological rule that says when there's the W at the end of a word and it comes after a consonant, you should delete that. So that's what allows a tim to just become a tim. There's a lot going on here. I know that that's not a super intuitive way of thinking about it for anybody who speaks Cree. If you really want, I can talk about that privately, but the point is these are rules that we've written to try and model the language. And we have an entire system of these with probably a couple hundred of these rules or these correspondences. And, this took a couple of years on and off to create. If you are doing it full time, you can get a pretty decent start if you're very familiar with the system in about a weekend. If you're completely unfamiliar with the system, as I was when I started, it's going to take you a little bit. It'll probably take you a couple months to get used to the programming. And then it'll probably take you a couple more months if you're doing it full time to create a full system. But the advantage of something like this is that it allows us to create resources that are smart and can recognize, for example, various forms of a single word. So on this dictionary, when I write the word jumping, it does give us the word jumping, the noun, opiuin, but it also gives us the guascoto, I believe, form he or she jumps. It recognizes that jumping with ing at the end is a verb form of the verb stem jump. And if we were to click on that, we would see some more interesting stuff, but that's going to be in the next set of videos. Alternatively, if I take the third person plural form, this guascotawak, apologize for my pronunciation. If we take this form and search it, we can see we're given they jump is the sort of first thing. It's the black word there, or they make a jump. And then it gives us underneath that the base verb form without the WAK, just with the W. And so it recognizes that this is the third person plural form of guascoto and gives us that as a result. Machine learning methods, on the other hand, deal with what we call artificial intelligence, or AI. You've probably heard that around actually a fair bit, especially recently. AI, artificial intelligence, just mean we are getting a computer to learn rather than teaching it. The idea with this is that we can give it unstructured data and it'll learn, if not exactly like a human, similarly to a human. The easiest way to think about how machine learning works is to think of it as a combination of labels and data. So the first step is that a computer is given labeled data that has a description of what it is. We call this the training data. In step 2, a computer associates the label with some underlying structure in the data. I won't go too much into this. Actually, I won't go into it at all, but it manages to associate something underlying in the data with the label that we've given it. We have not told it these underlying features. It figures it out. The computer then looks at a bunch of data that doesn't have labels and tries to guess them. Once it's guessed the label, in step 4, it compares it with the label that we gave it and sees if it's correct. Did it get the correct label? If the guess is correct, that's awesome. Great, let's move on. Make a note of the fact that your association was correct. If not, it takes a look at what it got wrong and what it got right, and then it starts again. And it goes through this process over and over again until it comes to either a particular accuracy score or until it goes through the number of steps that you've told it to. So you can say, repeat this process 100,000 times. Eventually, then, what you want to do is take this model and test it on data that it was not trained on. So what does this mean for language data? Well, let's take a look at, again, a real-world example. This is, again, using Plains Cree. So the leftmost column here in its own red box is the data. We can think of that. This is the stuff that we are feeding into the machine, into the thing that's going to learn. Then the labels are basically everything else that we have going on here as a chunk. So in this case, the second column in the black box is the lemma, or like the dictionary form. Then we have a tag, so whether or not it has a preverb or it's part of speech. We have that again. We have a third column of that if we need, and so on and so forth. So these are labels. We don't really need to know what they mean for right now. You just need to realize that we are associating these features with the data. So for example, on the third line, we are associating kayas with the dictionary form kayas and the tag plus IPC. Alternatively, we are associating the nistotam with the dictionary form nistotam and the preverb ta, the fact or the tag that says that it's a verb, the tag that says that it's a TI verb, the tag that says that it's a independent form, and the tag that says it's a third person singular form. So what we're feeding it here are, on the leftmost column, a bunch of words, or we can call them tokens, which just means that they're different words. And then everything else is what we can call a grammatical analysis, or a parsed version of it. The machine system will then learn and associate the forms on the left with the analyses on the right. Then what we would tell it is, okay, we want you to guess. So we're going to give it, in this case, the exact same words, and we're going to say, given the data, so just the things on the left, we want you to create labels. We want to create those tags yourself. And then it does that. In the sort of cyan or like bluish green rectangles, we can see these are errors. So if I flip back really quickly to the last thing, we can see, for example, that the third to last, this Ewe Wickenamak, is a word, Wickenam, with a preverb letter E, plus verb, plus TI, plus conj, plus one plural. But our system guessed that it was just an IPC. Alternatively, this done is to dumb, it thinks it's a TA when, the actual label is a TI. And then finally in this Nikisketen, our system guessed that it was a third singular, but in fact it was a first person singular. So we tell it, you got those wrong. You should probably go back and relearn them because you didn't do a super great job. So it goes back, we give it again the correct data, and then after we do that a number of times, we give it data that it hasn't seen before. So in this case, we just gave it 4 words. It got the first 2 correct. It got WIA incorrect. That's what that blue rectangle again means. In this step 6, this testing on new data, all that we did was we fed it the new data, and then it created these labels. So everything in that second red box is created by the system. And one of the cool things about machine learning is that this basically works on any sort of system. So what I mean by that is it doesn't just work with text. It doesn't just work with pictures. It can work with audio as well. In pictures, you might say, I'm going to give you 1,000 pictures of a dog. They're all labeled dog. I'm also going to throw in 500 pictures of something that isn't a dog, just various things that aren't dogs, and we will label those not dogs. The system will basically learn to distinguish between dog and not dog. And then when you feed it a new picture, it would say, oh, I recognize this as, and it would guess. The general process can be used for audio as well. So you can give something a transcription, so a written form of an audio file, and if you give it enough of that, it will start to associate certain sounds with certain letters. The thing about machine learning, though, is that it requires a lot of data. A word parser, like what we just saw, where we give it a word and it gives us a set of tags that describe the word, ideally you're going to be using millions of words for that. Few, if any, indigenous languages of North America, or in the world actually, have millions of words of text. There might be a way around this, which is something called bootstrapping, where you take a smaller amount and basically repeat it over and over again, and hope that your system doesn't focus just on that and becomes really, really good at only guessing your small set. Because ideally you want to be able to present this new information that it's never seen before, and it gives you a correct guess. But you can do that. That's one option. Even then, you still want a couple 100,000 words to start with. Anything less than that, and it starts to get a little bit fuzzy, at least right now. It used to be the case that you needed much more than that, but as technologies have developed over the years, things have gotten much better. I think even 5 years ago, systems were not at the level that they are now. Working with 100,000 words like I am was just not possible 5 years ago. And 10 years ago, very little, if any, of this was possible. So things are progressing incredibly quickly. And, if given enough data, training doesn't need to take all that long as compared to creating rule-based models. So because you're not going through writing rules, because as the researcher, you understand the rules that were given to you, and then you've turned them into computer rules, a machine learning model can actually be a lot quicker. The only thing is that you generally need a really good system to do this. Almost anybody's computers that we have here are going to be really bad for machine learning. Machine learning, put simply, it's basically, hundreds of millions or billions of guesses done all at once. So there's, in 1 second, a billion things happening in the computer to create a machine learning system. And the items in a computer that are really good at doing simultaneous processes are called graphics cards. And graphics cards are basically the gold standard for doing machine learning. The issue is graphics cards, good graphics cards that are very powerful and can do more operations every second, are incredibly expensive. But even more so than that, right now, even if you have the money, they can be really hard to find. And that's because there's in 2021 summer, there's a global chip shortage, which is resulting in not enough physical materials to create graphics cards to do the machine learning. So, if you're lucky and you have the technology, like you work at a university that has access to high performance computing clusters, or you can use these cloud services that allow you to use their graphics cards. They're not too expensive, but there's the data sharing issue. If you have access to the great technologies, the physical technologies that exist, it can actually be really quick. I can train a 10 million word model, I believe, in about 8 hours. It uses 4 of the world's best graphics cards, but I can do it in 8 hours. But that's not realistic for everybody, and as a result, it might actually be quicker or easier, at least, to just do a rule-based model. But the advantage of doing the machine learning-based thing is that you don't need explicit descriptions. You don't need, as the researcher, to understand the rules that you're trying to teach the computer, because the computer's doing the learning. So if we go back to the previous example, we have our data here and we have our labels. In this case, these labels were actually created by a rule-based system. So we taught a computer through years of creating a rule-based system that, for example, if you have TA dash at the start of something, put the plus PV / ta tag, as in the first example. However, a lot of times what we actually find is that people have recorded elders or various speakers of a language, and they've written everything down and they've done their own analyses. And even if they don't have a straightforward grammatical description that you as the researcher can turn into computer rules, as long as they have, for example, a set of words and those words' analyses, they don't need to break down what each part of the word means. If you have enough of the data, you can give it to the system, and the system will figure it out on its own. So a computer learning or a machine learning model is actually able to learn things that humans might not be as quick to learn. The biggest downside, though, with these is that they do require an understanding of programming. If you've never programmed before, you're going to need a bit of an introduction in order to start making a machine learning system. You may also hear machine learning described as a neural network. That just means it's a particular technology for machine learning, and that's what we've been talking about. Or deep learning. Again, it's the same concept. But yeah, these are the advantages of these machine learning systems, is they can do these things in ways that humans are slower to do. Except kids, because children are able to pick up language super quickly. All right, let's just do a quick comparison of these two ways of building a language model. So to start, we have the basic and intelligent systems. The basic systems, they can take as much data as you want. They don't really require language models, so whatever you have is what you can put up there. You don't really need any programming experience for them, or you need like very little. If you want to create a website, obviously you need to know how to do that. But there are, pretty basic introductory ways to build websites, like WordPress. Scope of use. So these basic non-intelligent systems can be basic dictionaries, word lists, picture lists, so on. And limitations is that a basic system only handles exact words given to it. So if you don't tell it the plural form of dog, it will not know the plural form of dog. And in this one, you actually have to say, you have to say this is dog plural. And times to build, they're just generally pretty quick. So these can be done, depending on exactly what you want to do. Within a year, you can make an entire website with tons and tons of resources. For the intelligent systems, let's start with rule-based. For a rule-based system, you need a basic description of the system you're modeling. So you can't create a morphological analyzer, like the one that we saw, a word parser, if you don't know what different morphological properties are. You can't create something that tells you a word if you don't know what a word means, right? Programming experience, intermediate or advanced, you need some programming experience. It's probably not something that most of us are going to do, at least as of right now. Anybody here can learn how to program. It just takes time. It's not difficult. Everyone here is smart enough to do it. Scope of use, rule-based systems are good for creating smart dictionaries, which we'll talk about later, grammar checkers, parsers like we saw, conjugators, spell checkers, etc. The limitation of this is that it only handles words that it's been created to analyze or generate. So basically, if you don't tell it how to construct a plural form from the word dog, it's not going to know that that's dogs. And in order time to build, it depends how familiar you are with the system or who you're working with. But, if you're working with someone who knows how to build one of these, we've done it over a weekend. It's not going to be a perfect system, but it's going to be a really good start. Then finally, the machine learning systems, for the data, you basically need tens of thousands or millions of examples of the speech, the word, the pictures, whatever you're teaching the computer. The programming experience is intermediate or advanced. You might not need to be a professional software developer to start fooling around with these, but you will need to know how to program or work with someone who knows how to do some programming. I would not consider myself a software developer in any capacity, but I'm working with these sorts of systems. They can create smart dictionaries, grammar checkers, and conjugators, just like rule-based systems. The advantage, though, is that they can guess unseen forms. If you train a system correctly enough, they can guess a form that it's never seen before, which the other systems can't. And in terms of time to build, hours or days depending on your hardware that you're using, but it's usually much quicker. And one thing I'll also add is that a machine learning system is sort of by definition not going to be perfect. It's going to guess some things wrong. In the same way that like a human sometimes gets things wrong, even in a language that they speak natively. They might guess that a word means something that it doesn't, or they might give a weird form of a plural. It's not so much wrong, but when a native speaker does it, but an alternation. But usually these machine learning systems, the best ones can reach about 99% accuracy. So they're, with the right amount of data, they're very accurate. All right, so that's the end of this little introduction. In the next set of videos, we're going to be covering electronic dictionaries, both basic ones and intelligent ones, and we'll compare and contrast them. I know that this talk was a little bit technical. None of you need to know how to build any of these things. If you want, we can talk. But really what I want you to understand is that the differences between rule-based systems and machine learning systems, and the difference between systems that have a language model and systems that don't have a language model, and the advantages and disadvantages of those. So if you have any questions, as always, send me an email. If not, I will see you all in the next meeting.